Hey everyone, welcome back to another TxePrep calculus video, and in this video, we're going to talk about finding the derivative of functions like sine of x, cosine of x, as well as e to the power of x. And first we're going to start out with the derivative of sine of x, and we're going to use the limit definition of a derivative to help us prove that. And as you may recall, the limit definition of a derivative states that f of delta x plus x minus f of x divided by delta x, and the limit of that as delta x approaches 0 is equal to f prime of x. And obviously we need an f of x to help plug into the function, and since we're trying to find the derivative of sine of x, that means our f of x should be sine of x. So now let's plug that in. So when we plug that in, that gives us the limit as delta x approaches 0 of sine of delta x plus x minus sine of x divided by delta x. And we might seem stuck over here because sine of delta x plus x isn't exactly cancelable with sine of x, and there doesn't seem to be anything obvious. But luckily, trig identities come and save us over here. And so we can rewrite this using trig identities as the limit as delta x approaches 0 of sine of delta x cosine of x plus sine of x cosine of delta x minus sine of x, all divided by delta x. And what we can do now is I'm going to factor out sine of x from the top. And that leaves me with limit as delta x approaches 0 of sine of delta x plus times cosine of x. And then here comes a factoring plus sine of x times cosine of delta x minus 1 divided by delta x minus 1. And all of this is divided by delta x. So what I'm going to do now is actually break apart these fractions over here. So instead of having one continuous fraction, I'm going to break it apart into two different fractions. And that means I can split up the limits. So I can rewrite this as the limit as delta x approaches 0 of sine of delta x cosine of x divided by delta x plus sine of x times cosine of delta x minus 1 divided by delta x. And I'm actually going to rewrite this even further and put this in parentheses over here, and same thing applies over here. I'm going to put this in parentheses. And since we have the limit as delta x approaches 0, we find that we have ourselves with some really well-known identities for limits. So the limit as a variable approaches 0 of the sine of that variable divided by that same variable is equal to 1. So we can just simply rewrite this as 1. And the same thing applies for cosine of delta x minus 1 divided by delta x. When we take the limit as delta x approaches 0, that's simply just going to leave us with 0. So this is going to be the same thing as 1 times cosine of x plus sine of x times 0, and that's just simply cosine of x, meaning that the derivative of sine of x is simply just cosine of x. So now let's take the derivative of cosine of x. So now that I have the derivative of cosine of x, what I want to do now is try using the limit definition to help find it. So what we do is the limit as delta x approaches 0 of cosine of delta x plus x minus cosine of x divided by delta x. And again, we have to use trigonometric identities to help us simplify this expression with cosine. So what that equates to is limit as delta x approaches 0 of cosine of delta x times cosine of x minus sine of delta x times sine of x. And then obviously minus cosine of x at the end, all divided by delta x. So now what I'm going to do is factor out a cosine of x from these two terms over here. And when I do that, that leaves me with the limit as delta x approaches 0 of cosine of x times cosine of delta x minus 1 divided by delta all over delta x minus sine of delta x times sine of x. And what I'm going to do now is actually break this fraction apart like I did last time, so we can apply some similar limit properties over here. And I can obviously break the fractions apart. Now I can do separate limits. And when I do that, that gives me the limit as delta x approaches 0 of cosine of x times cosine of delta x minus 1 divided by delta x minus sine of delta x times sine of x divided by delta x. And delta x, when I plug in delta x into cosine of delta x minus 1 divided by delta x, and when that's approaching 0, that simply just becomes 0. And sine of x over sine of x times sine of delta x over delta x is equal to just sine of x. So this becomes cosine of x times 0 minus sine of x times 1. And that's simply just negative sine of x, which means the derivative of cosine of x is simply just equal to negative sine of x. So now let's take the derivative of e to the power of x. And when I take the derivative of this, I assure you you're going to be really surprised with what our answer turns out to be. So let's let f of x equal to e to the power of x and take the derivative using the limit definition. So the limit as delta x approaches 0 of e to the power of x plus delta x in parentheses minus e to the power of x divided by delta x. So now we're going to factor out e to the power of x from both of these terms over here. So this leaves us with limit of delta x approaches 0 of e to the power of x times e to the power of delta x minus 1 divided by delta x. And when we try using substitution for delta x, as delta x approaches 0, when we try plugging in 0 for delta x, that just leaves us with 0 over 0, which is an indeterminate form. So there must be some other way to simplify this. And in fact, there is. You must have known that the limit as delta x approaches 0 of 1 plus delta x to the power of 1 over delta x is equal to e, which means that e to the power of delta x is simply just going to be 1 plus delta x. And we can actually substitute that over here. So when we do that, that gives us the limit as delta x approaches 0 of e to the power of x times 1 plus delta x minus 1 all divided by delta x. And obviously the 1 and the 1 over here cancel out, and the delta x over here cancels out, which means that this is simply just the limit as delta x approaches 0 of e to the power of x, which is simply just e to the power of x. And it turns out that the derivative of e to the power of x is simply just itself. It's e to the power of x, which means that it's actually going to be really useful in future examples and problems, because it is actually a really helpful way of simplifying things out.